Okay, so assignment 2, task number 7, is all about solving equations that involve trigonometric functions, sine functions, for example. And these are the two they want to have a go at. Use sketches or graph plotting software, so Autograph would be ideal for this, to justify the solutions in part A. And I'll talk about that when we look at some examples. So let's have a look at 1 or 2 examples. First of all, as a reminder, before I left you, we looked at these. You've got them written down, so I'll pause it if you really want to make a note of these now. In fact, let's do that. You could always get these off this video clip anyway, okay? But they're in the textbook and we've looked at them. So these might come in useful in solving equations, as we'll see. But these are sorts of things we've been looking at. These first few are the basic ones, where they talk about actually some definitions. What does the secant mean? Just 1 over the cosine. What does the cosecant mean, or cosec? 1 over the sine. What does the cotangent, or cot, mean? 1 over the tangent. And you remember we talked about these having to be defined because sec, or cos to the -1, does not mean 1 over the cosine. It means the angle whose cosine is. So we need something else to represent the inverse, which is secant in this case. And then we came up with a few identities that you can arrive at from those and from Pythagoras. So that's those. And we can use those to solve equations. Let's look at an example. Solve this equation, 6 sine theta plus 2 equals 0, for angles between 0 and 360 degrees. So I have here a sine wave that I've drawn out, and you could plot this on Autograph. So you remember in the task it says use a sketch or Autograph to justify your answers. So this is a sort of sketch we're looking for. So let's solve the equation and see how that relates to this. 6 sine theta plus 2 equals 0. What we're after is theta. So what do you think we might do first to get theta on its own? -2 from both sides. And divide by 6, okay? Sine theta -2 over 6, -1 over 3, minus 0.3 recurring. So sine theta equals negative 0.3 recurring. So it's just like an algebraic equation. You do whatever you do to one side, you do to the other. If it's a trigonometric equation, we're then often left at the end with the next step, which is to find theta. We find the sine whose angle is theta. So theta equals sine to the -1 of 0.3 recurring. So then you reach for your calculator and you get an answer. What is that answer? 17.46. Negative, by the way, so negative 17.46, did you say? So 17.5 rounded, 17.5 degrees, okay? What angle has got a sine of negative 0.3 is the thing here. So let's look at this sketch. If I go back to the sketch, where on here is negative 0.3 recurring? Well, here is negative 0.5, so negative 0.3 is here, so negative 0.3 recurring is about here somewhere. That's the angle there, okay? Which is not 17.5 degrees, okay? What the calculator does, it gives you the first angle between 0 and 90, which is here. The calculator works in this quadrant of the cycle, this first quadrant of the cycle. So it's giving us this one, 0.3 recurring, which is That's your 17.5 degrees. So it's giving us positive values. What we need to do now is understand that if we're after minus 0.3 recurring, which is here, negative 0.3 recurring, we're actually after this angle, which looks as though it's just about 200 degrees, and if we're between 360 degrees, this angle here. Sorry? That looks like a 5 to me, but I think it's supposed to be 300. Okay, 360 takes us to here. Right, so what we do now is we take into account the fact that this thing is symmetrical. 0.3 is here somewhere, and so that's 17.5 degrees. So how do I find out what this angle is? This is 180 degrees, isn't it? What will this angle be? 180 minus 17.5, so we might be interested in that one, but we're not. We're interested in this one, so what do we do? Right, 180 plus 17.5 will give us this angle. 180 plus 17.5 is 197.5 degrees. What about this one? No. Well, think about the symmetry. This is 17.5 degrees here from there. So what's this going to be? Right, 360 minus 17.5 degrees will give us this angle, which is 360, 350, 342.5. Those two angles, 342.5 and 197.5, have a sign of minus 0.3 recurring. Okay. What is, use your calculator, what's the sign of 197.5? Minus 0.3, so that's correct. Are you in the right? Alex, you might be in radians if it's not working. Okay. What's the sign of 342.5? Should be the same, okay? So going back to the start of this question, just to summarize this, solve this equation. If you're asked to solve an equation, we need to know within what band we're interested, because if you think about it, there's an infinite number of angles that have a sign of minus 0.33. This wave carries on to infinity. So you need to specify within which band you're interested in. 0 to 360 degrees is common. So the calculator, once you've gone through the algebra to get to this, the calculator tells you the angle in the first quadrant here. What you then need to do is to sketch the wave and work out what angles we're actually interested in here from the symmetry of the wave. Okay.